We're going to continue our coverage of Java semaphores, and we're going to talk about some of the key methods. I suspect you've probably figured some of these methods out already because it's not too complicated, but I want to talk about the richness of the methods defined in the Java semaphore class. And you can see there's a lot of them. So let's start with the most fundamental methods, the key methods that are used to acquire and release a semaphore. So you can see here that these methods under the hood use the abstract queued synchronizer framework. I mentioned that very briefly last time. We'll talk a bit more about it, and you'll get to see how the methods work. But that's how the implementation works for Semaphore. Very, very similar to the way the implementation works for other synchronizers like Java reentrant lock, for example. Acquire atomically obtains a permit from the semaphore. So its job is to get you a semaphore, or in this case, when you call acquire, you get one permit. Anybody who's ever seen Agents of S.H.I.E.L.D. will understand why this is funny. The acquire method can be interrupted. And what that means, and we'll talk about this in more detail later, but it means that if another thread wants to interrupt a thread that's blocked trying to acquire a semaphore, if that thread is blocked using the acquire method, then an interrupt request from another thread will cause the thread that's blocked in acquire to return, and it will basically throw an exception, which indicates that it'll throw the interrupted exception. There's also another method called acquire uninterruptibly, which obtains a permit from the semaphore without being able to be interrupted. So you really would only use this if you are very, very stubborn and you want to ignore interrupts under all circumstances. It's like putting the please do not disturb sign on your hotel room. There's also another method called try acquire, and it will obtain a permit, one permit, if there is a permit to be obtained when the method is called, and only when the method is called. So it will not block. It's a non-blocking call. The untimed version of a try acquire, which is the one we show here, has a strange semantic, and it will barge. In other words, it will not honor the fairness setting. Remember we talked about there are two different types of semaphores, fair and non-fair semaphores. Try acquire will not honor the fairness setting. It'll just try to get any permit that happens to be available when it's called. There's another method we'll talk about later that does a fair non-barging try acquire. And then we have release, which is kind of the inverse of acquire, or acquire uninterruptibly, which atomically increments the permit count of the semaphore by 1. And one thing that's interesting about this is it's perfectly valid for the permit count to exceed the initial permit count. So the initial permit count is what you give when you create the semaphore. You give it the value n, where n is the number of palantiria or whatever. And you can increase release stuff to make it go above the initial count. That is usually a bug, but it's possible to do it with the API. And the way that the semantics work is if the permit count is now greater than 0, a thread that's waiting to acquire the semaphore can then proceed. And the thread that's calling release need not be the thread that called acquire. So in other words, semaphores need not be fully bracketed. They might be fully bracketed, and in particular for our programming assignment with the Palantir manager and the simulation and stuff like that with the beings, we use the semaphore in a fully bracketed manner, but that's not necessary. And we'll take a look at another example here shortly that uses two binary semaphores, where the threads take turns acquiring and releasing each other's semaphores. There's boatloads of other semaphore methods above and beyond the 4 that I just showed you. To do your assignment, you really only need a handful of these. You need to know acquire, the non-interruptible acquire, the interruptible acquire, and release. That's all you need to know for the assignment. But there's also a lot more methods. Some methods can acquire or release multiple permits at a time. So you can see all these methods take a permit count, and it'll basically block until that many permits are available. There are also some methods that use timeouts, like try acquire. There's try acquire that takes a timeout, and also one that takes a timeout and a permit count. And the timed try acquire methods do in fact honor the fairness setting, and they don't barge in line. Barging is just, if you remember when you were in elementary school and you were waiting in line at the cafeteria or wherever, and someone barged in line or cut in line, that was considered rude. So the timed try acquire methods don't barge, whereas the non-timed ones do. And then there's a whole pot of other methods that get you other information. There's one that tells you how many permits are available on the semaphore. There's something that tells you the number of threads that are waiting to acquire the semaphore, and so on and so forth. So there's other methods. These are not necessarily all that useful in practice. They're only useful for like diagnostics and debugging, because they're always an estimate. In a concurrent program, whenever you ask the question, how many permits are available, or how many waiting threads are there, that's always a snapshot in time. And moments later, nanoseconds later, something could change. So you can't really take these numbers to the bank. They're just there to give you guidance. And you typically wouldn't use them in real programs. You might use available permits maybe, but it's still uncommon. So that's the end of the overview of key methods in the Java Semaphore class.